Okay, let's go. Let's do it. Last time we were studying AWS was directory buckets. So let's see. Want to disable the dark mode. Doesn't work. This is actually this is directory buckets and objects management. Wait. Working with objects. I mean, that means whatever we can do in an object, in a directory bucket, is what we see here. So most of the operations from regular S3 buckets are supported and available for directory buckets. That's a fact. Not all of them. There are some features that are not supported. Like what? Well, I got that in a different page. C2. A use case for low latency. So what doesn't work here is MFA deletion, S3 select, static web hosting, versioning, etc. Doesn't work on S3 directory buckets. Multi-part upload is supported. Expiring objects, delete incomplete multi-part uploads. That also works. Okay. So now what we have is working with objects. So lifecycle, uploading, listing, deleting, copying, downloading, signed URLs, it's supported. Security now. What about the security for directory buckets? Support both kind of server-side encryption using S3 managed keys and also KMS, which is key managed service, I guess. What is AWS KMS? Encryption service. What KMS stand for? AWS Key Management Service. That's what it is. Key Management Service. Very good. So that's security. Let's see. Data protection and encryption, which is server-side encryption, KMS encryption, monitoring default encryption, directory buckets. Yeah, I guess that's done by CloudTrail. Server-side KMS, directory buckets. So here explain how it works. Authentication, logging in with CloudTrail for directory buckets. So we can use LogTrail to monitor all actions on the objects, from listings, deletions, uploads, etc. Support with CloudTrail to monitor uploads, deletions, listings, heads, etc. Optimizing directory performance. How you can optimize that? Not quite sure. Developing with directory buckets. This is regional and zonal endpoints. You use S3 console with SDKs, CLI as well as available. That's pretty much it. Working with directory buckets. Working now with Amazon S3 tables and table buckets. So this is how we can query things in AWS S3 without having to list the entire tree of objects we have in a single bucket. Instead, we use S3 tables for that. So that's going to be a different topic. And bucket tables. Okay, let's go. We got a lot of things going on here, which is table buckets, S3 tables, maintenance, namespaces, tables, analytics integration, analytics services integration, accessing tables from open source query engines, AWS regions, endpoints and quotas, security for the S3 tables, logging in with CloudTrail for S3 tables. So quite a bunch of things supported by S3 tables. So what's the difference between S3 tables and table buckets? So from the start we have two things here. Number one is S3 tables. Number two, we have table buckets. Okay. Integration with analytics services is in preview release, and it can change over the time. That's a note. Okay, let's go. How this works? S3 tables provide storage that optimized for analytics workloads. S3 table is in S3 storage, actually optimized for analytics workloads. Purpose built for storing tabular data, such as daily purchase actions, streaming sensor data. Tabular data represents data in columns and rows like a database table. Wait, is S3 table not a... All right, yeah, that's right. This is S3 tables. It's not S3 select service, which is where we can query metadata. This S3 tables is basically a storage service where we can store tabular data. Tabular data. Set tabular data. Come on.
From our Vertex AI dashboard, we create a new tabular dataset.
Tabular dataset. Tabular.
Tabular data creates a
tabular data. So it's another storage way. So I was wrong. This tabular data column storage service. Nice. And the data is stored in table buckets. In format Apache Iceberg format using standard SQL statements. You can query your tables with query engines that support Iceberg, Apache Iceberg format. Stored on table buckets. Data is stored in, this is Apache Iceberg format. Iceberg format for SQL queries. Features of S3 tables. Purpose-built storage for tables. Higher transactions per second, which is expected. It's gonna be just a stream of charts, a string of text, basically. It should be low latency, but this is higher transactions per second. Better throughput. Built-in support for Apache Iceberg, obviously, because that uses the SQL format of Apache Iceberg. So it can be queried with the standard SQL things, yeah. With Iceberg, you can change how your data is organized, so it can evolve over time without requiring automated table optimization. Yeah. Querying S3 continuously perform automatic maintenance operations. Compaction, snapshot management, on reference removal, access management and security. Supports AAM organizations. S3 tables is the namespace. So that's good. AAM, I guess policies. It supports AAM policies via S3 tables namespace. Good. Analytic services integration, yeah, but not that stable for now. not that stable as of now. You can use now AWS services with S3 tables to support your specific analytics applications. Athena. You can use the following AWS services with S3 tables to support your specific analytics applications. Okay, let's take a note on this. Integrations. Athena, Glue, AMR, Redshift QuickSight, Lake Formation. So this is a tutorial getting started with the street tables. Region analytics service next. So we have a bunch of steps. Step 1, 2, 3, 4. 1, create the tables and integrate with analytics services. Create a table namespace and using AWS CLI. Grant lake formation permissions on your table. Query data with SQL in Athena. Okay, it's gonna use Athena. It's gonna create the table, give it permissions, and to the lake formation, and query with Athena service. So let's see. First step: go to console AWS Amazon.com/S3. Create table bucket. Interesting. Step 2, create a table namespace and table using the AWS CLI. S3 tables is gonna be the namespace. Create -namespace table bucket ARN. Okay, namespace, my namespace. Okay, so first we need to create the table bucket, and then we create the namespace. Then create a new table with a table schema. And what's the table schema? Well, I mean the properties, the schema itself for the table. Nice. Okay, I need to take notes on this. Demo. Create table bucket. Then create namespace. Then create schema. Create a schema. Okay. So then in permissions to lake formation, which is gonna be, I guess, AWS AIM, and some permissions in there. Then query with SQL Athena. Go to SQL Athena, add data into the table using insert command. Okay, we can start writing into it with SQL from Athena service. Okay, use Athena to insert and read data. Good. Table bucket. So what is this now? Our S3 table buckets are S3 bucket type that we can use to create and store tables as S3 resources. Tabular data, tabular data, interact with table stores inside your table buckets. So it shows how to create what is a table bucket. Getting started. I think I went back. Table buckets. Yes. Naming rules. Nothing that is special with naming rules. The regular standard ones, which is, let's say, the characters long should be 63, from 3 to 63. The name can consist of lowercase letters, numbers, and hyphens. It cannot contain periods, underscores, cannot end with a letter or a number. Must begin and end with a letter or number. The rules: create a table bucket, we saw that already. From S3, from CLI is using S3 table. We specify the region and we say to create it. Delete a bucket. View table bucket details. Managing policies. Maintenance. S3 offers maintenance to enhance the performance of your S3 tables or buckets. So what does that mean? That it means that if I don't enable maintenance, it's gonna have a price, I guess, then my tables are gonna be slower and slower without maintenance. Jobs can run periodically for your S3 tables or table buckets, and you can see that by calling the get table maintenance job status. Next topic, table bucket maintenance. Yes, interference, file removal, consider limitation, table maintenance, compact target file size by using AWS CLI. It has configuration, snapshot management. Type iceberg. So what does that mean? I can generate snapshots manually. Considerations and limitations. Compacting and snapshot creation is what supports. Let's see. There's 3 tables. Maintenance. Data compact. Snapshot. Yes, CLI. All right, namespaces. How to create each table name must be unique. So this is basically rules for the naming. You can create up to 10,000 namespaces. So a bucket can have 10,000 namespaces. 10,000 namespaces. How to create? Using query engine. We can use Spark as well to create the tables. How to delete, and what are the tables now? The data is stored inside a table bucket as a sub-resource using the Apache Iceberg table format. Okay, data is inside the table, which makes sense. How to create a table? Wait, isn't this the bucket? Isn't it the bucket? Create table. Oh, that's the schema. Wait, what? So we create the table bucket, then we create the namespace, then we create the table or schema, right? So here we are defining via create table. We are defining the schema. So schemas also create a table, so don't get confused. Let's don't get confused. Create table. Wait. Delete a table. Managing policies. Table policy. Okay, integration with other services like Athena, Redshift, AMR, QuickSight, Data Firehouse. How to integrate via service role. AAM service role. Data catalog is the service that needs to be put in place in order to get the data from the S3 table and stream it to somewhere else. Tables are populated as tables in their respective databases using S3 tables catalog namespace. Obviously, it is required first to have the table bucket, obviously. Resource link. Okay, I don't get this. This seems to be too much technical. I need to do this by myself. I need to do a lab for it. Redshift integration, AMR integration, demo, how to do it. Create the cluster, the role, Spark shell, and start using the table. Okay. QuickSight, never use that. Data Firehouse. Seems Glue ETL. Glue ETL is not on my list. Glue, it is there. Amazing. Accessing tables from open source query engines like Apache Spark. Endpoints. So let's say support for Apache Spark. Tables, regions, endpoints, and service quotas. S3 tables. Okay. Has its own region and endpoints. Regional endpoints, right? Regional endpoints. And then in the namespace is S3 tables. So that's being consistent across CLI, regional endpoints, everywhere. Quotas, table buckets, 10, the default. Per region, 10,000 namespaces, 10,000 tables. Okay. Security for S3 tables. So what about the encryption, I guess, identity-based policies for access, resource-based policies, identity-based, resource-based, organizations, encryption, in transit, yes. The regular, it supports the regular. What is regular? Security. What's this? Identity based. Identity based. Resource based. SCPs. Policies. This is for AWS organizations. Encryption, in transit, and at rest. Encryption, transit, and at rest. Okay, access management. That is identity and resource based. S3 tables for the policies, list, rename, update, get, put, delete. So pretty much the crude permission support. Identity based. Now we have more technical. We are going more technical here. Policy that has the version statement that can have a bunch of statements. Each statement has the statement ID, effect, action, an array of action, and a resource. Resource-based policy, which should be other services accessing to the S3 tables. So we gotta define the principle, the action, some conditions, AWS managed policies. Okay. Granting SQL semantics permissions. Oh, interesting. So we can fine tune up to that level. VPC connectivity should be done via endpoints, gateway endpoints. Yes, that's right. Restrictions and limitations. Public access not supported. Presign URLs not supported. Makes sense. But it's worth to know. It's worth to know. No public access. No HTTP, only HTTPS. Policies should be 20K in size. Okay. CloudTrail examples. Access control. Okay, yeah, that's a new thing. So it supports CloudTrail. Now let's go with access control in Amazon S3. Then security data protection. We're in the middle. We're still on the way. I thought I was ready, but no, there is a lot of things still to read. access control via identity, access management, AAM, access points, S3 grants, managing access with ACLs, blocking public access, review bucket access, verifying bucket ownership, object ownership. Okay, let's go. It's a lot of things. Access control in AWS S3. Every S3 customer likely has buckets with objects in them. By default, Amazon S3 resources are private. The root user account that created the resource owner within that account and necessary permissions. S3 resources. What are the resources of or things of S3? Bucket, object, access point, object lambda access point, multi-regional access point, jobs, storage lens configuration, storage lens group, access grants location, access grants, etc. There are two types of S3 buckets: general purpose buckets and directory buckets. Yeah, I know. Categorizing S3 resources. It's not useful for organizing them. But you can also set access management rules based on the resource categories. In particular, prefixes and tagging are two storage organization features. What? Okay, we have two types of bucket. Access control, does that work for both of them? I guess yes. Prefixes, what's this about? A prefix in S3 is a string of characters of the beginning of an object key name. Yeah, tags, identities. Is the person who created the bucket or the object? Is the owner. By default, root user of the account. Identities that don't own a resource can request access to that resource. The subject who created the object or the bucket becomes the default owner of the resource. That makes sense, obviously. If not, root is the owner. If, say, the user is removed, doesn't exist anymore, then the root should be like the fallback, I guess. When you have new team members who require S3 access, they can use AAM, users, groups, roles, and give permissions to them via policies. That is the AAM identity provider access. They can have MFA, anonymous user, which means public users. It's possible as well, which basically share the anonymous user. By default, S3 is not public, yeah, we know. We know that. Access management tools. I mean, what? The following are the access management tools available in S3. Bucket policy. Okay, that's a good list to know. Access management tools. Bucket policy. And now this. Identity based. S3 grant access. Grant access. I need to review that. Access points. How's the permission? Can you have 10,000 access points attached? For each access point, you can enforce distinct permissions and network controls to give you detailed control over access to S. Oh, interesting. Access points. So each access point can have different rules. Access control list, ACLs. Grant basic read or write operations. S3 specific schema. So it supports ACL. Object ownership. Also use object ownership to turn on ACLs by default. ACLs turn off, bucket owner enforced. ACLs turn on, bucket owner preferred. So if ACLs is enabled, then we will have object ownership feature enabled. Ownership. Some other best practices: block, public access, versioning, object lock, object encryption, signing methods. Wow. The AWS account owner or bucket owner exceeds access policy size limits. These are troubleshooting scenarios. And it triggers or starts, this fires up with identity-based access, identity and access management for S3. Here we go. Policies, AAM users, federated. Alright, this is gonna be great, crazy. Identity access management, AAM. Identity access management. AAM didn't have to write it all. Just AAM. Okay, let's stop there. Wanna see some laboratories on it. And cloud, it's gonna be a tool to help me understand a little bit better this. Come on. I'm reading AWS 3 documentation. Directory packets, yes. Packets and objects management. Show me some Terraform examples to understand better and practice myself all the theory learned based on the documentation. Then I need to check S3 tables, and then I need to check access controls. Thinking. Preparing Terraform examples. Oh, that was fast. Okay. Terraform require providers, HashiCorp 5, provider configuration, and let's see. S3 directory bucket creation. Where is it? Okay, S3 directory bucket creation. Name, location. The directory bucket is a local zonal hosted resource, so not regional. Must be created in S3 Express one zone location. It will have a policy for what, I guess. For what I might say. I might say S3 access role. We can create this get put. So before accessing to the directory bucket, we need to open up a session. Get the current ID, AAM role for S3 access, reference in the policy. Okay, it's creating the role, and then it is creating an object based on a TXT file. It's creating an alarm metric. So it's gonna evaluate what? Average storage bytes. So basically it's gonna see how bigger is the directory bucket when it exceeds 1 gigabyte. So that's it, pretty much good example. Another example. Creates the bucket, defines some files, PDF, PNG, CSV, JSON, and then the content files. For each file, upload them to the directory bucket. So I use AWS S3 object, and I upload the objects into the directory bucket. I establish a encryption server-side algorithm, and I have a null resource for what? It's creating a session, and it is pre-signing all the objects in the bucket with 3,600 seconds of expiration. Depends on, creates the policy. What is this bucket inventory? Bucket inventory, destination, CSV, weekly. What is this? I never saw that. Another example is gonna be data processing. Directory bucket being created, lambda function to do what? Where we specify where the function is, and bars create the role, policy, a CloudWatch event rule that's gonna be triggered every hour. CloudWatch event target, event rule, event target, lambda permission, VPC endpoint. Oh yeah, now in order for the lambda to connect with the directory bucket, we need an endpoint, a gateway endpoint. Yeah, a gateway endpoint. Cool. We specify the route table, some policies, and we create a dashboard. Oh, what a cool way to create a dashboard. Dashboard body, JSON encode, and we specify how we want our dashboards to be. Dimensions, type, metrics. Really cool. Nice. Lot of details. Now Now show me some examples on how to use S3 tables, and that's it, with TensorFlow. Okay, so let's see how to use S3 tables, which allows SQL-like querying capabilities on data stored in S3 buckets. Okay, TensorFlow code, definition of the providers, creation of a regular S3 bucket data lake. Wait, why? Shouldn't be S3 bucket table, something like that. This is a regular bucket. We have versioning enable, S3 policy. What? Okay, a policy where we have S3 get object on this bucket. We have glue, so this glue is going to do something. Catalog, database, catalog table, external true, we classify compression type of data, delimiter, and a bunch of configurations. Like a data ops engineer should be able to understand a little bit better this. Okay, we have the bucket, we have the data lake, we have glue, we have a role and a policy for glue to do things. Is that it? Now this is the S3 tables basic setup. Is this for real? Just like that? Something's wrong. S3 tables with Athena integration. So not creating. Okay, let's see. AWS S3. They will create names TensorFlow. It's too new that it's not available on HashiCorp language. Maybe. TensorFlow delivers launch day support for Amazon S3 tables, EKS hybrid nodes, and more at reInvent. Oh, nice. So my cloud AI is not being able to provide me a good TensorFlow code because it's outdated. S3 iceberg on top of S3. Yeah, that's the Apache iceberg. How to play? Now we can see it here. Resource AWS _ S3 tables. Table bucket. We have table bucket policy. So this is pretty much new, brand new thing. Well, from December. Now we are March 5th. Okay, so let's see if we have that in the documentation. So it's pretty much new, and I might not be able to test it using TensorFlow. Well, I should be able, because we have documentation. So something is not working here, which sucks. Oh no. This sucks. Okay, S3 table. It has to start with AWS. S3. Doesn't work. Space. What? Okay. TensorFlow S3 tables. Seems not to be available yet. Seems this S3 tables not to be available yet. Okay, we have S3. Let's go to where? S3 resources, S3 simple storage, and we know that. Can I put T bold? Wait, no. Oh god, S3 table. Oh yeah, we have that here. S3 table underscore table. How to use? Say the namespace. We can even create the namespace. We can create the table, the policy. Pretty much should be available here, but I'm not able to use the underscore. How to use it? Anyways, it works. Let's copy paste this, and we should be able to see this here. No, it is not there, so I cannot trust devdocs.io. No, there's nothing like that. So, I don't have that from enabled. So enabled. So S3 table. No, let's copy paste. S3. Oh, not available on devdocs. So now something needs to be rebuilt here. Okay, let's go with access control. Well, we're still reading theory, so no need to do that for now. Okay, let's have a break. So that's it basically. It's easy to complete it. Some labs are pending in there with things related to S3, AAM policies, CloudWatch. We need to also add some networking and storage laboratories. And then in order to close this all, we need to use auto-scaling and load balancing. Just a little bit. Don't go too far with EBS, networking, load balancing, and auto-scaling, because we are going to have a different session study to go deeper on those services. Right now, focus is in EC2, which is mostly instance types, AMI marketplace creation, etc. The hardware architecture underlying the EC2 service, types of operating systems, CPU architectures, CPU vendors. What else? And the different capabilities based on the architecture, vendors, hardware for memory optimized, compute optimized, GPU optimized, burstables, CPU types, and a bunch of operational things like SSM, CloudWatch agents, monitoring costs, some accesses, identity-based, resource-based, AAM policies. Need to check more on CloudWatch and CloudTrail as well. The storage with the different kind of volumes, with different capacities and optimizations for the operating system, for the data, for cold or slow access data, networking, multiple network interfaces, static defined IP addresses, and a bunch of things, public IP addresses. This thing about the placement, something really interesting as well. Placement constraints. What is this other thing? Capacity reservations. Then after that is how we can buy the compute service via on-demand instances, reserved instances, spot instances, dedicated and shared tenancy features. There are other things that I'm not interested in, but I know that it exists, like EBS-backed instances or instance store instances. There must be some specific cases where we don't need to have the data like a container, and we want to use a serverless, stateless kind of instance, so we can go with the instance store functionality. And I'm also forgetting about jobs, AWS jobs, batch jobs, which is also important and part of EC2. So a bunch of pending labs for EC2, and S3 is getting added to it as well. So let's go with Django documentation. Let's open up cloud. Let's go now. Let's refresh. Let's resume. So where we are at right now, and I'm hungry. Oh, still we are chapter 2. We're not able to finish chapter 2. We're still in the beginning. So let's review what was the last thing. I remember we were looking into models, model creation, relationships, and about the CRUDs, how to create, read, update, delete objects via operations using ORM. But the most interesting thing was how to read, how to fetch data, where we can fetch one single data, making sure we are using try and catch exceptions. We can pull or fetch a bunch of data. We can filter, and we can sort. We can filter, we can exclude. Filter and exclude, both options are available. And then we can sort. We can sort based on using column-based sorting. So let's review that. Let's review it again. CRUD operation: many to many, many to one, one to many. Yeah, we can do the .get, .all, which is going to basically pull. We can do order, ask, desk. We can filter. We can exclude. And we can use lookups inside of filters and exclude to make sure we are doing operations like greater than, lower than, greater or equal to, or than, contains, starts with, ends with for the strings, and the same works for both filter and exclude. We also had a queue object where we can do more complex querying or filtering or query to complex objects that have multiple relationships. And how does that work? Select SQL delete operations, update operation, ORM, data migration, the Django migrations, we know how that works. But I need to repeat my testing because I'm forgetting how to type all of this. We have a model example, which is book. What's this model? A book and a contributor. Oh my god. I need to check that pretty fast. Pretty quick. Pretty fast. Joulish, contributor. Come on.
Fertilizer, a big contributor to greenhouse gas.
Contributor.
In the 1980s, another protein, tau, emerged as a possible contributor.
Crisis. The global food system right now is a huge contributor to this.
Thank you very much. Okay, let's go. Relationships, yeah, I know that. One-to-one relationships, many-to-many, one-to-one, one-to-many, model strength, migrations, creations, using foreign key, many-to-many, create using .save, .create, and all that. The .add. Do we have that? How to create objects using .add? Many-to-many. Set, add. We specify one given object, or we can use book that contributors dot add. And dot set. That's another one. Okay. Need to test this by myself. Create and set methods for many-to-many relationships. So in this case we have a publisher and we have a couple of contributors, and we do, and how we add the relationship. We create a book, so we have publisher, couple of contributors in a book, and then what? We do book contributors dot set, and we add the contributors. What it's missing here? Publisher is what? Oh, it's part of the book, so we can ignore that. Book that contributor, we can use .add or use the .set and add a bunch of contributors in there. Read operations. So we have the get method. What is the all method? Yeah, the .all method, and we know that. We also have the filter method, and we have to specify the column to filter, obviously. Where's the lookup? Okay, publication date underscore greater than, and we specify a date. Less than or equal to, greater than or equal to, contains, exclude also works, yes, we know that. Order by, and we'll specify the column, ascendant, descendant. Querying across relationships. Book title. What? Okay, so a publisher can have a bunch of books, so we're saying publisher, that object, that get, and we specify one of the books title. So it's saying give me all the books that have this title and that belongs to this publisher. And how we specify the model, and the property of the model is underscore. That is a query across relationships. Okay, let's take notes. That is reading, basically. Reading, like a lookup. And so let's add here Django. Still reading. This is an relationship. Relationships. Okay, dot get, for example. Objects that get. It's gonna be, for example, we will use publisher here for my reference, and book underscore title equals whatever. So easy peasy. Gates. Easy peasy. Filter. So this is interesting. We are fetching all the books, but that have the publisher called Pocket Books. So the other way around also works. Interesting. And also, relationship queries works with the filter method, and we can have a chain of filters. One filter, two filters, multiple filters. Nice. Okay, that's one too many. Now we have a many too many. What's different? Okay, let's see. It also works for filter. So what does this mean? We know that book and contributor have many-to-many relationship in this exercise. Without creating an object, you will perform a query to retrieve all the contributors who contributed to reading the book, title, the talisman. Contributor, yeah, objects.filter. So we're pulling all the contributors, and we are doing book underscore title, and we'll put the title. So we get all the contributors. Many-to-many query using objects. So this is a filter using fill lookup. Yes. And now what's this? Using objects. Contributor.objects.filter. Book.objects.get. What's the same thing? Interesting. So basically this is pulling all the books called the talisman, and we're pulling the contributors, which is another field of the books, isn't it? No, it's not. It's another table. Okay, that's good. Other way. Or just get all books and get its contribs. like book equals book objects get, and we filter by something like title, and then we get in C, let's say, book objects, no, I'm sorry, book contributors dot all of them. Simple. Using the method set. So why the set? Why book contributor book set all? In this exercise, you will use contributor object to fetch all the books written by the contributor named Rower. So what? Contributor, I get all of them. Book set. Since book and contributor have too many relationships, we can use the set method to query a set of objects associated with the model. In this case, contributor book set all to turn all the books written. I don't get that one. I will need to say that in action. We are almost to the end. In this exercise, we will use updates. Okay, updates. So this is what I did before. Updates. How to change something. For example, the first name. So we get the contributor by last name, first name. What? Where are we updating? To update an existing record. Oh, that update. Oh, one line thing. One line. So it's pulling with filter all the contributors named with the last name, title. And we are doing then that update. So we are changing the name, the first name to Mike. Nice. Delete. So it's gonna be the same. We do a dot get or a dot filter, and we do dot delete. Yeah. All right. Cool. This is update. Update. Delete. Pretty easy. Update. Delete. Delete. And that's it. We are done populating. Populate. Execute the custom managed command to populate the database. CSV. Okay. We need to learn how to populate. Research. And Django command to populate DB, preferably from CSV files. Nice and easy. Oh. Let's see now. Let's see some examples before to go. Okay. Extended. I'm reading here. Django documentation on models. Give me code examples so I can exercise and test on a local Arch Linux environment because I am a hacker. Okay, I need to test models, creations, migrations, and relationships, CRUDs, filtering, excludes, complex queries, and all related to Django models. Okay, be a good guy and show me some examples. Show me some examples. So what we have in the documentation? Models, query sets. Query sets, something that I need to learn. Model instances, migrations, raw SQLs, we don't know, aggregations, transactions, multiple databases, custom lookups, query expressions, conditionals, database functions. Wow, this is a lot of things related to models that we will need to read the documentation to learn about that. So it's first we are learning about models and databases. Then we are going next with the view layer. The view layer, URLs, and how we present the information. So that will require templating. And after that, we can go with forms, development process, configuration, admin, security, internationalization, performance optimization, geographic framework, common web applications, tools like caching, logging, sending emails, pagination, RSL, serialization, sessions. I mean, all of that is important. It's not like a bunch of nice common tools. Some other functionalities: conditional content processing on redirects, safe framework, Unicode. So why is not that part of the structured content from above? Right? It's like, a bunch of nicer things, and it's put at the end of the documentation. Let's see, Django REST framework, because it has specific views for REST. Where is the documentation now? Funding requirement, installation, example, quick start, development, support, tutorial, community, tutorial, API guide, topics, serialization. Yeah, I need to serialize my information before sending it out to the client. Part 2, working with, okay, this is really fair enough. Part 2, requests and responses. We can customize that. Part 3, class-based views. This is really cool in order to save a lot of code, to do pretty general printing of our code. Authentication and permissions. Yeah, this is amazing. Relationships and hyperlinked APIs. The first part I seem to understand, relationships, and we have pagination. Part 6, view sets and routers. Yeah, this is pretty useful as well. Trade-offs between views and view sets. View sets can help us to save a lot of code as well. And that's it, Django REST framework. Okay, let's see what that is. Okay, I'll create a comprehensive guide with Django models code examples that you can practice with on your Arch Linux environment. Setting up Django project, model creation, migrations, CRUD, querying, filtering, complex queries, advanced model operations, admin interface, testing, signals, advanced features, proxies model. Wow, inheritance. Yeah, that's great. View integration, class view. Forms, URL configuration, setting up URLs for views, fixtures. Great. No. Give me more examples related to models and how to validate and test using Django tests or Django shell and different case scenarios or fictional projects. Go. In the meantime, let's see what we got at the beginning. Can't see this, so I need to stack edit this. No, I got a bunch of things here. Okay, let's split this. Let's remove this all. Let's paste this. Let's make this one single column and let's study. So in order to create a project, we will go with pip install Django, Django admin start project. Yeah, we need to start the project first. Then we start the application. We add the app to the settings. We create some models. Django DB, Django utils, it's being used here. So we have an author class here, which using chart field, data field, text field, date time field. So date time is created at, updated at. No question about it. It's a regular thing. Regular things to do. Chart field, chart field, text field. I need to use both of them. Data field, date time field. I need to use both of them as well. Auto now add, auto now, both of them true. Okay, what is this meta? Oh yeah, pre-configuration of the table, metadata information. Ordering is gonna be by one specific column. Verbose name plural. Authors. Yeah, metadata information of the model. I will need to specify how that's being used in a database. So I need to start using MySQL or Postgres instead of SQLite because I cannot query it. It's ugly and sucks. I need to use a real database. Publisher, let's say publisher has a chart field. Am I saying this right? English. Chart field, chart field. What's this? How is this?
SQL, so there's a char field, varchar fields, text, which will be a character field or a char field, meaning I want the user to type in
character field, char field. All right. Both mean the same, but they're pronounced different. Okay. We have an author here, publisher model. We have category, and we have the class book. Again, let's go again, so I don't forget. Author, publisher, category, and we have the book itself. We have language choices here, something to pick up, like a static, like a dictionary, pretty small database. We have a dictionary to use here to define the language. Okay, what does a book have? A title, ISBN, publication date, price, language, and that's going to be a choice from the dictionary. Page count, what does that mean? How many pages? Can be a positive integer field, so it's not a number, it's not an integer, it is a positive integer field. We have Boolean field and we also have image fields. We have a bunch of fields: char field, text field, decimal field, date. What were that? Date time field, date field. Now we have positive integer field, Boolean field, image field. Now relationships. Here's where the party begins. The book has an author, which is going to be used as a foreign key, meaning the book can have one single author. Is that correct? What does that mean? Cannot have multiple authors? Is that what you're saying, bro? Related names, books. I mean, that's the additional table. So it means we need to have, I mean, it is a foreign key, a one-to-many relationship. So foreign key, and we specify the object class, author. The class is what we're specifying, but where are we instantiating or calling that? Well, it's part of the same models.py file, so it can see it, can have access to it, Publisher, same story, foreign key. Related name, books. Wow. Now we have categories, which is gonna be a many-to-many field, and related name is books. That's an interesting thing to know, to test. Why the same related name? Maybe it's underscore books table that's gonna be created. Is new release. Okay, we have some functions, model functions to query things, to automate some data processing information. Is new release. Okay, has to be under 30 days, and if not, it's not a new release. Okay, we have the meta class, gonna be the default sorting by publication date. Indexes, that's good. Indexes, what is this? It's gonna use the title and ISBN as index fields. Okay, I don't know what's that for. Index field. It's gonna create more columns where it is going to hash each of them, the title and the ISBN for search purposes, or what? Then we have the customer model. It's gonna have an ID, UUID field, has a first name, last name, email, phone, joint date, which a date field. And it has a property which composed of two other properties. But we are using a decorator here, which called add property, which called full name, which returning the combination of the two strings, first name and last name. Now we have rental, which has a foreign key object, which is many to one, and the book is the object. Another foreign key, which is the customer, the person who is going to rent the book. We have the due date, the date, checkout date, the status. We have some functions, is overdue, save. Why we need to create our custom function, save? Is overdue and self-status different from overdue? Overdue, then self-status is overdue. Well, it's calculating this and it's using super.save. So what does that mean? Is it inheriting something? No, what the heck? What the heck? Okay, we also have reviews. Foreign key of the book and the customer. We have a rating, comments, and created ad fields. It has data information, where we have to specify that book and customer are unique together. Nice. Okay, migrations. Once all of that's in place and coded beautifully in your preferable code editor, then you can migrate, you can make migrations. So you have the code to be executed to create the tables. Then you migrate, or you can do it by a specific application. My migrations by application, and you can even have custom migrations. And you can, okay, I am saying here custom migrations. Okay, I will see that later. All right, so it's doing now Python shell. And it's gonna to invoke or instantiate all the models created before. It's calling the time zone from Django utils. And it's doing import date time. So why the time zone from Django utils and the date time from operating system? Or the Django built-in library? Okay, is this really doing inside the shell? Yeah, it is a shell. Author, objects, create. So, creating the author. Regular name, birth date, date time. I need to practice dates with Python. Okay, publisher. Objects create. Okay, publisher.objects.create. So everything is .objects.create, .objects.something. Creates categories. Okay. Now it's time to create the book. Title, ISBN, publication date, price, available, author, publisher. Now that book's created, it's adding their relationships. Book, that categories, that add, and I put a bunch of categories in there, or by IDs, which works as well. Then I create a customer, personal information. I create a Zental, an existing book, an existing customer, and then the current time based on the time zone. Check out the status. Then create a review. Review that objects.create. I specify the book, I specify the customer, rating, and a comment. Now, read operations. Get single object. Book that object.get. I specify the ISBN. By primary key as well, using the .get method. Okay, method.
And he decided upon reflection that his method of payment,
method,
combination of the scientific method and the artistic process.
So the D is what I'm missing. Method. Update operations. Book that price and I overwrite the value of it, and I do book.save. So I remember the last time I did that, it created a new object for me. Okay, .save is supposed to update the object. But why it's not using just the update? The update method. Method bros. Boom 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 boom. update specific fields. Okay, we get in a specific book by filtering the ISBN. Then we do that update and we change the price. Yeah, that's how I know it works, and I have that in my notes. Delete, review.delete the entire object. Delete multiple objects, like doing book.objects.filter. All of them that is available are equals to false. That's delete. Okay, so once my objects are created, I'll do creations and relationships. Once that is done, I'll continue with querying and filtering. I will use filters, I will use lookups greater than, publication date, year, and I specify the year. Oh, that's cool, pretty simple and smart to use. I know the publication date is a date-time field format. And I want all the books from 2023. I just need to specify _ year, and I specify only the year, so all the full days of that year should be available on my results, which is great. Available English books, filter by language and available, or filter is available, true. I can put comma separated filters in a filter method, or I can chain multiple filter methods. Exclude queue objects. So queue objects is the complex query that I didn't learn how this works. We're using the filter method queue, and I specify in there some columns. So pretty much, so no lookup. It's raining. It's raining. It's raining. So no need to use the lookup functionality anymore. I just need to specify the queue function and the parameters that I want to filter in there between parentheses. And I can use Boolean operations like and or. Hey, wait, and I can still use the lookup operations inside of the queue. Okay, that works. So the only benefit of using queue object is to use Boolean operations. And if I want to chain a bunch of conditionals in there for multiple lookups, I can use the not operation. Like queries, which is contains, starts with, ends with. I can use what's this? Sensitive uppercase, lowercase strings in array. Range of numbers. If I want to pull objects that are between ranges, starting from, ending on. Works with dates as well. Is null data queries. So data can get complex. Contains. Okay. Relationship queries. I know how that works. Author __, the name of the author, __, and I can put some lookups even there under distinct. Nice, this is really great. I need to review this again. Filters, lookups, chaining or using comma separated parameters for filter. Exclude using the queue object and Boolean conditions. Relationship queries using lookup. Null checks, data checks. Complex queries and aggregations. So what are those aggregations from models? DB Django models. is count, average, sum, mean, max, f, expression, wrapper, decimal field. Well, yeah. So I want to get an average, the average price of my books. Book.object.aggregate. So that aggregate is like do a calculation based on the result of this query. Dot aggregate, something new. And I need to take notes. Some more. Oops. Dot distinct dot average aggregate and I specify with average, with maximum, the sum of all the results. Annotations, what is this for? Publishers with book count. Annotate, I don't know, book count? Counts. Annotate? I don't know what's that for. Annotate, dot annotate. Calculate average rating for each book. Okay, this is interesting. Book objects. Annotate. Average rating equals to average reviews underscore rating. So it's gonna take the rating, the number. It's gonna do the average from all the reviews table for that particular book, and it's gonna do annotate. Find books with high ratings, average greater than 4. This is really getting amazing. Annotate, average, and filtering. Once we have the average, the annotate, and whatever aggregated function we put in there, we can still do some other filterings based on their new result. Not from the existing properties, but from the new one that we are creating, which is part of the annotation. The result columns. Using the F expression. What is that? Combine expression. This is really getting crazy. Advanced model operations. What are those? Bulk create. Interesting. Bulk update. Bulk update, but it's doing a for loop. Because it pulled the authors, it's modifying all of them, and it's doing bulk updates. I send the authors array which was modified, and I specified the biography, the field that was updated. No, it's pretty complex. I need a break. Custom models, methods. Yeah, the methods that have the model. Seems about right. Transactions, so this is important. Transaction atomic. It creates something. If anything fails, book and both author and book creations will be rolled back if something fails. It is creating the author, it's creating the book. Both should be able to be recorded in database successfully. Otherwise, rollback is gonna be in place. Admin interface. Yeah. Okay. It's creating classes for the admin. Author class, author admin, publisher admin, category admin, and it's registering in the admin package of the application. And we have the list display, search field. This is the UI interface. List filter, search field, list display. So we don't need to show up all the fields of the model. We can specify which ones. We can specify how to search by name, by some specific column name. The book admin is the more complex one. We have filter, display, search field, autocomplete, read only, field set, and we are even organizing how we want to present the information in the web interface by using field sets. Get query set. This is a lot of information. Rental admin. So we are defining how the web administration is gonna be for all of our models. Testing, so how to create testings. We need to import Django test case. We need a setup where we create some needed objects and we start defining the tests. So the author test has one single test, create author. Self.assert equal test author. So it got created at the beginning. We create it and then we evaluate if the author has the data that is expected to have. We do that the same for the book model test. We create the book under the setup method and we start creating tests. Book creation is new release. Test is new release. Couple of tests, that's it. Couple of tests. Wait, what? Test with a new book. Assert true. It's new release. Then it's creating an old book and it's testing if this new release assert is false or not. So it's running two tests in one single function. Is that good? We have a test for book creation, we have a test for new release functionality, and we have a couple of tests in there. Two asserts, assert true, assert false, and we are even creating an object. So we have the setup function that's just creating one of the books. Should be able to create both of them, but it can be used just one. So yeah, doesn't make sense. We have the rental thing, test, model test. We create some resources, author, publisher, book, customer, rental, and we start testing. Creation is overdue tests, and we run it all with test library. So where are these files? Do we have a test directory? Library tests.py, single file. Model signals, what is this? Post save, pre-delete, dispatch, receiver. This is getting really complex for me. Update book availability status when rental is created or updated. Okay. If I create a rental object, then the book object should be updated automatically with its proper. So an object is created, a row is added in the rental table that should trigger like a function, a SQL store function that updates the other table, the book table, and picks up and modify the particular book status column and change it from active to inactive, based on the case, depending on the case. The store book availability, so signals or triggers should be, or dispatch maybe. What is this? Advanced model features. Custom manager. What is this? Custom manager? Book manager. Available, new release, by category, get query set. So what's this? Return, self-filter. Is this like pre-filter, queried class? Book manager seems to be like a book factory where you query like something like get me books by category, and you just specify the category, and inside you have the complex query with that filter or the queue object, whatever you want. and then you just use book.objects and the custom functions you created. And it's not the .all, it's not the .get, not the .filter, not the .exclude, the custom function you created, like new releases by category, available. Interesting, amazing, got it. Abstract models, what for? Let's create an abstract. Proxy models, ebook. How to use this proxy model? What is this? Model inheritance. I can understand this. Where is it actually being used? Media, audiobook. Media is something. Audiobook is going to inherit from the media model. Oh yeah, straightforward. ORM in views. Okay, this is working with views now, and I don't want to know about that yet. It's gonna use basically the same things from beginning. Get objects and print it out. It's gonna search. It's gonna return HTTP responses. It's gonna listen post request, REST, GET request. It's gonna render HTML with templates. Now it's using book class-based views. Query get book detail views. It is using forms, widgets. Yeah, I know that it's pretty complex later then. Right now I just need to focus on models. Fixtures or initial data. Okay, it's gonna be a pain in the ass. It's a lot of things. Wow, I asked for one more example and it created, wow, like a full project. Okay. Okay, I need to replay something. Quick. What? Go. New client. Okay. Oh no. Why just partial time? I need full-time job, not partial time. let's go. So now I want to go sleep a little bit, but let's go now with reactjs. Yes, React documentation. I want it to be quick because I've been learning reactjs. I mean Vue.js, cloud. Alright, let's see. Should be quick. Should be quick. A bunch of things were missing here. I have a tic-tac-toe. Okay, using React uses JSX, more stricter than HTML, requires one root tag as part of the views. CSS use property. The component can have and handle events as functions inside the component. So each component can be independent. Okay. Export the full function. Export the full function and the name of function. Return one root can be empty, but it has to be one root HTML tag. HTML tag. JSX displaying data, conditionals, rendering lists, responding to events. Yeah, you know that. Updating the screen. Use state. Okay, what's this for? You will get two things from this use state. Count, and the function that lets you update it with set count. You can give them any names, but the convention is something, set something. The first time you hit the button's play count will be 0 because you passed 0 to the user state. Okay, so what exactly is this? Where is this being used? What you want your component to remember some information. I guess this is temporal. Using import use state from React. So let's now okay, hooks. What is this? Okay, if I click this one time and click one time, so I have two buttons, and we're using use state. We have two buttons, each of them have the count and the set count starting from 0. When I do the on click, it triggers the handle click function and updates the set count. Pretty straightforward. Okay. Counts the variable being stored in React. It's not raining anymore. Hooks. Use state. Hooks shared between components. Oh, okay. Data can be shared between components, but how? So they can always update together. Okay. Via hooks, right? Okay, I need to see that. The function. Well, the count is being moved off outside of the component, it's being moved at the root of the application, meaning like it's becoming like a global variable instead of a local variable which is inside of the component. Now it's global, so obviously it's going to be available for all the components. Yeah, it's going to be available for all. That's what's that? Is that a hook? Yes, it seems to be. Okay. Use state bars. Okay, use bars. Constants. Can be used on the component. Or the main root component. So it's global. Okay. Tic-tac-toe. You will build as a small tic-tac-toe game during this tutorial. This tutorial does not assume any existing React knowledge. But this tutorial does not assume any existing React knowledge. Okay, just show me the code. Use state square and tic-tac-toe is build, 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 build. Oh, you won, motherfucker. Okay, use state. Function square. Value on a square click. And it's a turn on a button. Ah, wow, what? Confusing thing. So each button is like an history. I can go back to my previous move in the tic-tac-toe game. So that's why this function is. I specify the value, which the button is, and it will take me out. No, it's just a button definition. I'll click on a square click, then the square click function should be somewhere around here. It's a pretty long. I want to see this full screen. Cannot see it like this. It's pretty annoying. A square. It returns a button. Both should be the game in the screen. Is next squares on play. Handle click function, which does some calculations. Next squares slices XO to print on play. What's the on play function? Okay, then it calculates the winner, which is another function, defines the status and prints out winner, next player. So a bunch of logic there, and then it returns the HTML. The HTML is going to return a div, a bunch of divs with the buttons and its listeners. Oh well, 3 rows, kind of a table. HTML, but it's composed of squares objects and 3 rows, like building the tic-tac-toe interface. The full function game. Explore the full function game. I mean, this is the main application. It's using use state, which is gonna be the zero tic-tac-toe game. It's going to state to save, to store the movements, clicks, underplay, jump to, moves, history. It's storing the results in a history variable, which is a map. Yeah, that's the history I'm seeing here, where I can go back to that specific moment. Calculate the winner. Ah, nice. Pretty nasty JavaScript code, but interesting. What's this? In the left color, you click forward in the top right corner of the editor and start using the website code sandbox. Code sandbox lets you write code in your browser and preview how users will use the app you created. Okay, overview. Inspect the start with code. So I see a button, a square. Wait. We are creating a function. Export the default function square. Export the default function square. Yeah, no. Class name. Export the default function square button. Use the interface square. So what is happening here? Strict mode. Create root. React on client. The styles. Okay. It is explaining line by line. Building the board. The square is gonna return a button, regular button with the class two buttons. We should expect to see an error. Yeah, because it has to be one root tab, no multiple. Okay, so it's creating one by one. We read the code already, and here it's explaining line by line how to build that step by step. Same code, going one by one, and explaining it over the time on the way. Okay, we can call that neat. Hungry. I'm reading. Of some reason, bad idea to use it. Here, there. Okay. Now let's see some examples. Reading reactjs documentation. Give me some small web app pages written in reactjs using reactjs. Fictional projects using TypeScript and work on machine. Give me all the commands and code examples to practice myself. Okay, let's have Cloud AI to give me some more examples to code myself. In the meantime, let's see a hello world example of PyTorch. Documentation, PyTorch. So where to start? Learn tutorial. Learn the basics. Yes, learn the basics of PyTorch. Yeah, let's see. React I will provide with several small practical React components using TypeScript that you can practice with on your Arch Linux machine. Setting up your environment on Arch Linux. npm TypeScript. Okay, npx create React app. npx create React app, the name, and template TypeScript. So that's gonna be my boilerplate TypeScript project. Example: a simple task manager component. We have a TypeScript, we have CSS, which I don't care. Okay, file has to be TSX opposed to JSX. Nice. Okay, let's try to understand the code. React. Now we are using use state use effect. Interface task, where we define the model pretty clean to use. Wait, what? Interface task that has properties like ID, title, completed, boolean, and a set of kind of dictionary list of items. Priority, tasks manager, a constant. React.fc, and then we have tasks, set tasks, new task title, set task title, new task priority. So it's using the use state to remember data locally in the browser. Then load task from local storage amount. It will get the data from local storage. Since it's empty, it will load nothing. Set tasks. Okay. If any task changed, then use effect and store it in the local storage. And then we have the functions. Add a task. If it's empty, don't store anything. If not, then create the task object with proper set properties and set it. Use the set task. Set title, priority, double task, and what? Delete task, filter tasks. And then there's a turn of the HTML code. We return a div with the title h2. We have a form, I guess, for filter. We have select menu with different options, I guess, for filtering. Add task. Oh no, this is the form to create a new task. We have a filter button, and we have a bunch of on-click, okay, class name, task list, and also we can list them with unordered UL and LI list item, unordered list. That's it, pretty much simple. And we have a bunch of CSS configurations. Okay, we are back and something is going on. Something is not working well. And low battery. Both of them. Amazing. That's it. Let's go.